Hey everyone, in this episode we take care of the last framing component of the entire house, and that is the stairs. These are pretty awesome stairs because they are winding and they are floating. Check this out. I would say the coolest part about this episode is how we build these steps. Check this out. We don't have stringers, and then they don't have any kind of deflection. So let's get into it. Stairs require a lot of precision, particularly related to the rise and run of them. What we are doing first is we are running chuck lines through the center, and then we are also running a chuck line as to where the column should end. Now, we came to find out later that the cube where we're building the stairs is short about 1.5 inches, so that's pushing us to the limit as to how big that column must be so that we can meet code on the shortest point. What you see on the screen is basically all the documentation we got for building these stairs. Now, this was provided by the architect, and while they look pretty cool, I want you to notice how almost every step has a turn to them, and we could probably build it. The problem with this is I can see us making a few mistakes here and there, and we would just have to do a lot of rework, and rework means more money. So I don't think it's worth it from our perspective. What we're going to be doing is we're going to be simplifying these steps to make it easier for us. The only thing I do want you to note is that we're going to be taking the rise and the run from the architect, and we're going to run with it. So let's go to the 3D model and I'll show you how I designed these stairs. It's been a while since we pulled out the 3D model, and that's really the reason why we're called Efficient Build, because we can 3D model everything. That means we can get perfect takeoffs, so we can do, I guess, more efficient builds. Cool, so let's get into the stairs. One quick thing I need to mention is we did not receive any kind of structural design as to how these stairs needed to be built. We just have the architectural drawings. Now, that means I had to come up with my own design, and because I'm not a structural engineer, I figured, well, let's make this as strong as possible. Let's take components from the house to build these steps. Cool, let's take a quick look at the center column first. Based on the dimensions, it turns out that I want this center column to be 14 inches wide, because by code, every step needs to go into the wall a minimum of 6 inches. By making it 14 inches, that means that 2 of my steps will go into the wall 7 inches, giving me a little bit of extra room. Also, because I'm not a structural engineer, I figured, well, I gotta make this as strong as possible, especially because my plan is to notch the lumber so that we can hide the stringers in them and we can have the floated stairs. I decided to make this out of 2x12s, and as you can see, I'm staggering them because they don't fit perfectly with each other. And so with this, I suspect it will be a very strong wall. Finally, up here, I'm kind of doing a little bit of a platform framing. So we're going to be building the first step, and then we're going to be platform building the second story as well. As far as the sides of the wall, what I decided to do is, of course, we're going to be putting anchors onto the concrete, onto the stringers. So these stringers will be put there. And then the reason I decided to come up with that design is because one of our flat roofs uses basically ledgers that get attached to the wall. So I decided to steal that design from the structural engineer and say, well, we can probably put a ledger here on the concrete and then on the walls above, and then that should be plenty strong to hold the steps. If it can hold the roof, it can hold the steps. As I mentioned, the architectural design was a little bit crazy, so what we decided to do is make as many straight steps as possible, and then we break the turn into 4 in this bottom story and into 5 at the top story. Here's a quick little thing about code. You can actually have the first 3 steps without a rail. So that's what we're doing right here. We're not going to have a rail so that it looks nicer. It's easier to access. I'm very happy about the way this worked out, because by having the steps floated, you have a lot of room under them to make it a storage spot. So with that, let's get to work. Look, we have light. But anyway, the reason I'm here is because I want to show you real quick how we take care of the ledgers going around the concrete, next to the concrete. First off, if you ever deal with concrete, you absolutely need to get one of these hammer drills. They'll pay themselves off really quickly if you use them a couple times. That way you don't have to deal with concrete. I absolutely highly recommend them. In general, there's more than 2 ways to attach components to the wall. There's ramsets that we've used for steel, and then there's these anchors. We've used ramsets all the time. The guns are really expensive. The ramset nail goes in and it sometimes cracks the concrete, so it doesn't actually hold that well. So I don't recommend that method at all. I actually had one of those guns while we were doing the steel, and the gun blew next to my ear and it left my ear ringing for like a couple months. Fortunately, it came back normal. But anyway, I highly recommend this method. You've seen us use this for the basement walls in the mechanical. These are anchors, and basically this little tip, once you hammer it into the wall, it kind of expands and there's no chance you're getting this off. And they are also very, very strong. They are safe. You just drill a hole exactly to the size and then you're set. Talk about the lumber here. Of course, you can see we have pressure treated lumber here next to the concrete. It's very important that it's pressure treated. It needs to be able to withstand humidity that gets emitted from concrete. Or if you have regular wood, you can put something like bituthene in between the concrete and the lumber. So that's basically how our ledgers are being held all around where we have concrete. I'm in the process of building a whole bunch of steps and treads, and this trick I learned from Tom Silva from Diesel House. I absolutely loved it because it's very DIY friendly. It gives you a super strong step or tread, and it looks super elegant. So the way we're doing this is we purchased some LVLs. These LVLs are 11 and 7/8. And one special thing, if you know how it works or if you don't, is the LVLs have the lamination going one way, meaning that they are super strong in this direction, but not as strong in this direction. Yeah, we could probably use the LVLs as steps and you would probably end up feeling a little bit of bounce. And because of that, we don't want any bounce. So what we're doing is we're ripping them to 2 inches. As you can see right here, effectively we're turning this LVL into like horizontal so that we can have all the lamination facing one way. Let me show you one that I have finished, kinda right here almost. So notice how I have the different cuts, and all the lamination is facing that way, giving us amazing strength in this direction. Another thing I want to show you here real quick, I ended up putting this little piece of zip at the front, and the reason I do this is because with all this length, it allows me to put a 3/4 inch finish on each side of the thread, and it meets my run width. Finally, of course, we do have these cuts on the step, right? So in order to give it shear strength, kind of like a subfloor, we're putting a piece of 5/8 zip sheeting, as you can see right here. We glue it, we screw it, and then we have a super amazing step. It's actually not that difficult to do. It ends up working super nice. So now let's talk real quick about the process. The table saw does an okay job, a pretty good job cutting them, ripping them at 2 inches. But our table saw is like 2 years old, maybe 3 years old. It's basically ripped, whatever needed to be ripped for this house. And it's sometimes not perfect, so we rip it. And then what we end up doing is we run it through the planer to make sure it's as perfectly flat as possible individually. And then once we have the assembly of the full step, we run it again. So that's how we're doing this. We have some triangular steps. Those are going to be more complicated. I'm still thinking about them, so we'll see them in a moment. I'm applying adhesive to the steps in between the LVLs and the zip sheeting. Why not, right? We had a lot of subfloor adhesive extra. So, and actually, if you ever go to like one of the trade shows, like for Hoover, you might go to their booth and stuff. They have this super awesome demo where they basically test, I think it's a subfloor with just nails. Then they have a second one that's just screws. And then they have the third one that's the top of the line with adhesive and screws. And you can tell the difference amazingly between the different versions. Even the one with screws, it kind of like bounces still, but when it has adhesive, it just doesn't move at all. I think it just provides amazing shear value. And well, because these are steps, they're going to get probably the most traffic of every other piece of tile or whatever we put on the house. So that's why I'm doing this. Plus we have a lot of extra. Why not finish it?
It's time to test our steps for the very first time, so let's see how it goes. They feel super solid and they are not even screwed to the stringers yet, so very nice.
I've been thinking quite a bit as to how to build these triangular steps, and I think I came up with a solution. So I think what matters the most is that they have a nice bearing point for them because they're so big. So what I came up with is, you might see here the column. This is 14 inches, and this is on purpose because I want to have 7 inches at the edge. So basically the step will go 7 inches into the column, and that's also kind of by code, because by code you need to have at least 6 inches. I made it 7 so that I could give myself a little wiggle room if we make a little mistake or something. You can see I drew a chalk line right here in the corner. This is exactly where this step needs to come into place, and notice how this is bearing well enough into the column. So what I will do next is, since I have a bearing point on this step, imagine this is the step, we have a little ledger, so the horizontal one coming in this way will bear on this side, and then of course, because we have this continuously all the way through the back, it will bear fully on this point. So what that means is this one will come in slightly into this. It won't be as great a bearing point as it could, but it'll at least have some meat that it can hold on to. Why don't we just build it, and it'll be easier to see once it's built. One thing about the assembly is because they're triangles, it's very difficult to assemble them with screws, because you might have your proper alignment, but as soon as you insert the screw, it starts to pull the members out of alignment, so that makes life really difficult. So what we ended up doing is we're actually nailing them together, and then we insert the screws. That way we have proper alignment. The drawback of doing that is nails have the tendency to squeak if they don't have the proper force or strength, whatever. So because of that, I am adding these 90 degrees brackets to all 90-degree corners. So for example here, these are very tiny and we're going to be nailing them with Ticos. So we're putting them on every corner. Obviously you might be able to see here they're a little bit high. So we're going to be using the oscillating tool so that they can insert into the zip sheeting. Of course, as you might be able to see here, I added some ribs because we don't want any bounce or deflection on these steps. So adding these little ribs at 12-inch on center gives us that support. And then of course, as you saw on the flat steps, we're gluing them and all that stuff. You can see here how we insert a screw, and then the screw comes in and then it pulls this member in. That's what we're doing, and I do like this assembly very much. I'm going to show you a few lessons that we've had from these bottom flights versus the ones that we're doing up there. We should be able to finish a lot of the steps today, the stairs I mean. So first off, you might notice here that we're putting these covers right here. While these steps are actually floated, they're technically not floated because we're covering them like that. But the reason we built them floated is so that we could learn from this, so that when we do the steps up there, or the flights, they work out pretty nicely. And we'll go there in a moment. So that's why you see this. One quick little thing is when setting the steps, we set them to the very front of the stringer, and then we put our little 3/4 finish in here, and then that way we end up with a little gap in here that is also 3/4, so that our finished material can fully wrap all the steps, and the expectation is that the material is 3/4. Now, come up here. Some quick lessons we've had about building this column, and that is when we were building the support for the triangular steps here that are doing the turn, we were actually notching a lot of the lumber. So yeah, that works. But the problem with notching is it takes a lot of time, a lot of effort and all. So we have a better solution up here, and that is to, instead of notching the perimeter, the outside of the lumber, is to build a center column and then build a bunch of ledgers. So that way all your cuts are 90-degree cuts instead of having to do this notching all over the place. So come up here now. One very nice feature that we have right here is that we decided to bevel these corners, and I'm really liking it very much. It's looking nice. We're going to be extending this bevel all the way to the second story. Now, right here where I am, we have a tricky situation because we were like, will we pass code? Because this space is very, very narrow. I was looking around and the code states that you must have 36 inches above the rail, meaning the rail doesn't count into the width of the steps. So what's this width? This is actually 37 inches, what we have right here. So when we add the drywall on the one side, drywall on the other, we should have the 36 inches bare minimum to pass code. But really there's not much we can do. We have concrete to one side, we have the column on the other, but at least I'm happy that we don't have to count the rail for that. For this second flight, the first thing we did is we built this little wall. This little wall is what's holding the stringers. Now, this little wall by itself is extraordinarily flimsy, so we needed to brace it somehow. And in fact, what braces the little wall is the step. So before we actually fastened the steps, we made sure that it was perfectly nice and plumb. Then as it was plumb, then we fastened the steps onto the wall. And now, as you can see, it's solid like a tank. So everything is kind of working like a system. You might have seen us use this gasket. This is a seal gasket that we use for the foundation to framing transition. We also put a big stretch on the steps. We're doing that because we want to minimize any kind of squeak. Does it actually do anything? Does it actually work? I'm not sure. I hope it does. We've seen the Perkins do it and many other people do it, so that's why we do it as well. And really, the steps don't squeak at all right now, so maybe it is working. Finally, as you might have seen, we have these crazy little holes right here. So we had to get creative because since we have the stringers hidden inside of the wall, we needed to be able to screw the steps onto the stringers. Talking about fastening, by now we're like a broken record. We always use these Simpson screws, the 6 inches, and we're not sponsored. It would be nice if we were. We used probably thousands of these kinds of screws throughout the house. We use it on the roof, on the steps, on the stairs, everywhere. You might actually see the stringers are actually attached with these 6-inch structural screws. At this point, you know we love them. This is what we're using. One of the things that I love the most is that they have a flat head, so when you sink them in, they come in nice and flat. Okay, so here I'm now on the second flight of stairs, and as I mentioned, these are actually floated. So in order to accomplish that, we're going to be wrapping these steps in the finished material, and you won't see this in this episode. It'll be closer to the finished materials when the house is getting close to finish. The difference between these steps and the ones downstairs is that we are actually centering the steps in between the stringers, and that's giving us 3/4 inch at the front, 3/4 inch at the back, so that when we wrap it around and you look perfectly from above on the steps, they don't have any gaps, because by code we need to have 4 inches of space in between steps maximum. If you come over here, you can see the little detail and how much simpler it is by us putting a center column and adding the ledger that's going to be holding the steps. So this makes our life significantly easier for building. We move much faster. What we end up doing here at the end is we just add lumber underneath this to support the ledger. And then finally here, if you come up the steps with me, so here you might see that we have the step, and this is a little bit of what I was talking about earlier. Is you can see the lumber is resting on this ledger, is resting on that ledger, and you can see all 4 pieces of the steps are bearing on something, and that's very important for us. That way we have fully strength steps all around. Just wanted to show you this in case what I mentioned earlier doesn't make sense. Hay que meterle la esquinita primero. The corner. We need to get it in. Huh? Okay. Yeah, primero is first. So we're doing pretty good. The most important step in the assembly of the turning steps is the center step. Despite all our efforts and everything we could not necessarily make these steps perfectly symmetric. And we're probably the only ones that know about it, and you're probably the only ones that know about it, because if you look at them, they look perfectly fine. But if there was a mistake in the center step, you would definitely be able to see it. So we put our center step first, and then we put 1.5 spacers in between them. So that's basically the spacers in between steps. And the 1.5 spacer makes sense because our finish is going to be 3/4 inch on each step. So that ends up adding for 2 steps, 1.5. So that's why we did that. First, we put our spacers on the straight steps up here and down there. So that defined this first step. And then we have our center step, and then we started to work our way around it. And with this, we can finish this episode. I'm super excited the way they turned out. When we started, I wasn't sure. We had to do a lot of thinking in a group setting and everything, but at the end of the day, they worked out pretty nicely. Now, I think I mentioned already that we hide the stringers inside of the wall so that they look completely floated, but we didn't only have to hide them inside of the center column, we had to actually fur out this wall so that we can actually hide the stringers under the steps, so that when we have all the drywall and everything, the steps will be fully floated and then they will look super awesome. Let's go up here and I'll show you some final details. I mentioned out there that we were furring out the walls. We don't really need to fur out all the walls. We don't need to fur out that back wall, but we might need to fur out this one so that we don't see the stringers right here. But it's not a big deal. This is a very tiny wall. Here you can see the nice craftsmanship of Zach and everybody else to finish the column. And then here we have some additional blocking for the rail. The interior designer came up with a glass rail. We'll have to see, we'll have to ask her, but a glass rail here with such a fat column, I don't know if it'll look nice. We'll just have to see what she says about it. And you know, with that, we can finish this episode. We absolutely have to thank Jayton, Zach, Danny, Armando, because they, for the most part, as you might have seen, they built the walls. We spent a lot of time thinking, okay, what's the stringer width and size and everything? And at the end of the day, everything worked out very nicely. So why don't we finish this episode with me giving you a full tour from the bottom up of the stairs, and we'll see you in the next one. Please consider liking and subscribing. And don't forget to comment down below. Commenting really, really helps us. Bye.